Okay guys, let's give it another go again today and let's look at parallel lines. We've talked a lot about angles, and really when we talk about parallel lines we're going to talk about angles more. So let's take a look and see what parallel lines are by definition and where all these angles could be. Okay, parallel lines are, first of all, they're in the same plane. Secondly, they never intersect. So let's take a look at two lines that meet that criteria. If I say that I'm considering this line, which I'll call line L, and this line, which I'll call line M, and I'm going to say that those are given to be parallel because I can't assume it, you know that. So we're going to say that given that line L is parallel to line M, and you see the notation that I used right there. And the way you mark parallel lines, because you always want to mark your figure, everything that you know for a fact, you want to mark it so you can really see it and use that information visually and process it. And you're like, well, okay, we've got two parallel lines, I don't see any angles. Well, I don't either, except straight angles, and that's not what I'm talking about. Almost every time we have parallel lines, we have them cut by a line that is called a transversal. That line, let's call it line S. It could be called anything. So that line S is called our transversal. Here's the way that is spelled. T-R-A-N-S-V-E-R-S-A-L. Transversal. Say it a couple times. Yeah, transversal. Alright, once you cut those lines with a transversal, now you've got angles everywhere, coming out the wazoo. You've got 1, 2, 3, 4, 5, 6, 7, 8 angles right there. So before we even start, let's see what we know about those angles. Okay, what if I look at these two right here on the bottom? What is one thing that you could tell me for sure about these two angles? Take a look at them, look how they're positioned and so forth. Good. Somebody said that they are a linear pair, and you're right. They're a linear pair, so they're supplementary and they add up to 180. Yes, they do. Well, somebody else is saying, well, so do those two right there. Yes, they do. So do these two, and so do those two. Every time you have two angles forming a linear pair, you have 180 degrees. So what if, let's say we're given that this angle right here is 60 degrees. And I'm just using a nice round number to make this really obvious as we go through it in quick. And you already told me that just simply because this was a line, that these two angles would have to be supplementary because they're linear pair, and you're right. So that means that that would have to be 120. And then someone was saying, well, so are those a linear pair? Well, okay. So that means that that would be 120 because those two angles form a linear pair. And somebody else is saying, hey, but those two are vertical. Yes, they are. Vertical angles are congruent. We proved that. So 120 and 120. And somebody else is saying, well, these are vertical. So that'd be 60. And these are linear pair. Hey, and they add up to 180. Exciting. Because it's all just, it fits together like the greatest fitting puzzle in the world. Okay? Now here's the good part. Here's the part that you have that is a little bit new for us, but it's a wonderful thing to have because it helps us do so many other things, and that is this. This angle right here and this angle are called corresponding angles. It's just their name. We all have names, and that's their name. Corresponding angles. And they're called corresponding because they're in the same positions. Their positions match, or their positions correspond. They could call them matching angles. They call them corresponding angles. So what I mean by that is that's the bottom right of this foursome, and of this foursome, that's the bottom right. And you know what? We have this great postulate. And you know, postulates are a friend because they give us needed information that we can use for the rest of the year, and we don't have to prove it. So we're excited to get a postulate, especially one that is as clear as this one. And it says that if, and that's a big if now, if you have two parallel lines then corresponding angles are congruent. If you have two parallel lines cut by a transversal, then your corresponding angles are congruent. So that's a fact that is given to us to use. So if we know that's 120, then that one corresponds to it, then that one is 120 also. Why? Postulate. Corresponding angles are congruent if lines are parallel. Done. And we can say, well, those two are corresponding, so they would have to be congruent. And we could say those two are corresponding, so they would have to be congruent. And these two are corresponding, so they would have to be congruent. We would be absolutely right. And once again, we've got a perfect match with these four, and it's a perfect fit all the way, any way you look at it. Vertical angles work, supplements work, linear pairs, everything works. All we need is some names for these angles, and we're good to go with this. So let me come over here and draw really the same picture. And this time we're just going to be making sure we know the names of them. And we'll have our transversal here again. And let's just number the angles this time. And it doesn't matter how we number them, but I'll just start and go 1, 2, 3, 4, 5, 6, 7, 8. That's all that it matters. Okay, now we already know which ones are corresponding, don't we? And that corresponding angles are congruent if lines are parallel. So let's name them anyway. What corresponds to angle 1? Right, angle 5. So let's put that over here, angle 1 and angle 5. And they're also congruent. If these lines are parallel, let's say they are, then 1 would be congruent to 5. Name another pair of corresponding angles. Okay, I hear you. You're saying angle 2 and 6. Good. Those are corresponding, and they're also congruent. Another pair? Right, angle 4 and angle 5. Good. I'm sorry, angle 4 and angle 8. Angle 4 right here and angle 8 right here, corresponding angles, and they are congruent. And there's only one pair, and it's 3 and 7, and I'll just put 3 and 7 for angle 3 and angle 7. So we've named all 4 pairs of corresponding angles, and we know they're congruent because our lines are parallel. So we just need names for our others. We already know vertical. 2 and 4 are vertical, 1 and 3 are vertical, 6 and 8 are vertical, 5 and 7. We already know those. We also already know linear pairs. Everywhere there's linear pairs. 1 and 2, and 1 and 4, and 3 and 4. Any two angles that make a line, lots of linear pairs. New names is what we're looking at. Let's look at something called alternate. That's an alternate right there. Alternate interior angles. I'm going to make a little shortcut. Well, by interior, they mean inside the two parallel lines. That's interior. And by alternate, they mean alternate sides of the transversal. So the alternate interior angles would be 4 and 6. Good. And the other pair would be 3 and 5. Good. And if we look at those over here, here's alternate interior. Our angle right here that's 120, and our angle right there that's 120. And those are alternate interior, and they're equal, aren't they? They're equal in measure. So let's see if we just think this through, if we think they would always be equal in measure. Well, we know that if the lines are parallel, and they are, we know that angle 4 and angle 8 are definitely congruent because they're corresponding angles. Okay, so the only ones we're wondering, would 4 and 6 always be congruent? These two. Now you look at it and you tell me what you think. We know 4 is congruent to 8. Can we figure out that 4 would have to be congruent to 6? Yes, we can, because what about 6 and 8? Right, 6 and 8 are congruent angles because they are vertical. So 8 and 6 are congruent. So now look what we've got. 4 is congruent to 8. 8 is congruent to 6. 4 is congruent to 6. Two things congruent to the same thing have to be congruent to each other. So 4 is congruent to 6, 3 is congruent to 5. Alternate interior angles are always congruent if lines are parallel. Are congruent if lines are parallel. Little abbreviation again. Okay, now instead of alternate interior angles, let's look at alternate exterior angles. So if these inside, right, these angles in between here are the interior, that's what I mean by interior, then 1 and 2 and 7 are 8, and that's what I mean by exterior. So if I do alternate exterior. Alternate now means opposite sides of the transversal. So here's the transversal. So opposite sides would be 1 and 7, and they'd be exterior. So 1 and 7 would be alternate exterior, and 2 and 8 would be another pair of alternate exterior. So let's just reason out whether we think those are going to be congruent in this example or not. And then whether we think it would always be true or not. Backing up over here, this one, this angle 1 is 120, and then angle 7 is 120, and those are alternate exteriors. And this one, 60 and 60, those are alternate exteriors, and they're congruent, so would that always be true? Well, let's see what we think. All right, we know that, let's go back to our 4 and 8. We're basing everything on corresponding angles being congruent because our postulate said that. So if 4 is congruent to 8, what is true about 4 and 2? Vertical angles, yay, it's all good. 4 is congruent to 2. So now look what we've got. We've got 8 is congruent to 4 by corresponding angles, and 4 is congruent to 2 by vertical angles. So by substituting, we get that angle 2 and angle 8, oh yeah, they have to be congruent. So we have that our alternate exterior angles, and I'm going to abbreviate, alternate exterior angles are congruent whenever you've got parallel lines. How good is that? Are congruent. That is wonderful because it gives us every bit of information that we need. And there's only one more thing. Let's look at this angle right here. Let's look at 3 and 6 here. And let's look at them over here. Do we think those are going to be congruent? Well, over here, angle 3 is 120 and angle 6 is 60, and no, they're not going to be congruent. We can tell it. We've got a counterexample right here. So let's see if we can reason it through and think about it a little bit. 4 is congruent to 2, that's for sure. And 2 is congruent to 6, that's for sure. But and 4 is congruent to 6, but we can't get 3 in the mix there of things that are congruent because it's not. But what we can get about 3 is that we can get that 3 and 2 form a linear pair. So they're supplementary and they will add up to 180, just like they did over here with 60 and 120. You know, they always will, because if 2 and 3 are supplementary because they're a linear pair, and 6 and 2 are the very same measure, well then if 2 and 3 add up to 180, and 6 is exactly the same thing as 2, then 6 and 3 will add up to 180 as well. So that's another very helpful piece of information to have. So our same side interiors, that's what we call those. We call them same side, because they're not alternate, they're on the same side, and they're interiors. Sometimes you'll have a textbook or a teacher who will refer to those as consecutive. It doesn't matter. Consecutive interior angles. It doesn't matter. What does matter is that they're supplementary. They're supplementary, so you have to understand it, not memorize it, work with it, until you get it. Oh, those are the ones that are supplementary. They're not congruent. The others are congruent. Let's do another example of this before we leave it. We need to have complete understanding of how that works out. Okay, let's take two lines here. Let's put our transversal through there. And let's say that we've got a number here, that the angle that's 45. We've got an acute angle that measures 45, and that's given to us. And it is also given to us that these lines are parallel, L and M, and that we have a transversal we'll call T this time. Cuts them in two places. So let's just quickly go through everything we know. We know our corresponding angle is congruent by our postulate. We know that our vertical angle is congruent by a theorem that we proved that vertical angles have to be congruent. And we know that that would be the case also. We can just pop those in that quickly. And then we go to linear pairs. Well, what adds to 45 to get 180? Subtract and you find that, really carefully now, if you don't want to mess up, I get 135 plus 45 is 180. So we know that's 135. So is that vertical. So is that one. And so is that one. So we can that quickly get all of our angle measures, and we look and we're like, oh yeah, I remember these two were supposed to add up to 180. Okay, now you're going to find parallel lines everywhere. They're not just going to be sitting there that obvious on the page. A lot of times you will have a figure of some sort, and it could be different kinds of figures. We'll talk about all of this in great detail later. But let's just say that we have two parallel segments, works the same way. And this serves as a transversal, but it doesn't stick on out, it's not a line. And so you don't have as many angles formed. So it doesn't jump out at you quite as much as this does, because the only angles that you've got with this transversal, and you make sure you stay on the same transversal while you're working these. So I'm on this transversal, then the only angle I've got is this one and that one. So if I'm inside between two parallel lines and I have a transversal, what did we call those? Well, we call those same side interior angles or consecutive interior angles. We said they were supplementary. So we know then that if this angle is 160 right here, then this angle has to be 20. And I don't draw the scale, I don't try, so don't assume that I do ever. And obviously that would not look like a 20-degree angle. But these add up to 180 because they're same side interiors. And that would not be the case if these were not parallel. So be looking, be looking for parallel lines and segments and sides and so forth. And whenever you see parallel, where does your mind go? Angles, angles, angles. And you just look for them and you just plug in what you know and use your thinking cap and figure out the rest. And you'll be surprised at how well it all fits together. Great day. We've got a lot more to talk about. Go take a break. I'll see you next time.